Day 442 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1233, remove subfolders from the file system. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given a list of folders return the folders after removing all subfolders in those folders. You may return the answer in any order. If a folder of I is located within another folder of J, it is called a subfolder of it. A subfolder of folder J must start with folder J followed by a slash. For example, /A/B is a subfolder of /A but not B. But B is not a subfolder of /A/B/C. The format of a path is one or more concatenated strings of the form slash followed by one or more lowercase English letters. For example, /LeetCode and /LeetCode/problems are valid paths, while an empty string and a slash are not. All right, y'all, so I could see how this question may seem a little bit confusing at first. So let's go ahead and take a look at these examples to make sure that we are doing this problem correctly. So first we'll start with example 1. In example 1, we have our input, which is a folder, which is equal to an array of strings. First string represents a folder which is /A. Second folder or second string is /A/B. Third string is /C/D. Next string is /C/D/E. And the final string is /C/F. The output is an array of strings /A. Then the second string is /C/D. Then the third string is /C/F. Explanation says folders A and B or /A/B is a subfolder of /A, and the string folder /C/D/E is inside of the folder /C/D in our file system. So let's break this down one step further because even then it may seem a little bit confusing. So what we're doing is we're basically looking for prefixes, right? Our prefix is going to be or is going to let us know if it's a subfolder or not. So as you can see, this right here, this /A is a prefix of /A/B. So since we can find this prefix right here, we know that this is a folder, right? So that's why we could return it. Then we come down to this string right here, /C/D, and we have /C/D/E. Now, if we just had a /C, which we don't, then this would be a subfolder of /C. But since we don't have a /C, then this is going to be a folder in and of itself because this is a prefix to this folder right here, right? So if we would have had a /C, it'd be different. It'd be similar to this /A, and we would be able to use that /C as its root folder. But since we don't have a /C, but we do have a /C and a /D, and then we have another folder right here, which is a /C/D/E. Since we have this prefix right here, then this becomes the root folder, and we return this /D. Similarly with this folder right here, if we had a /C, if we just had a /C just like this, then this would be the root folder, but we don't have that in this array of folders. So that means this /C/F is its own root folder because there are no other subfolders after it. So we just return this /C/F, right? So just know that we're looking for prefixes and understand that since that this can be that we can have we can have a /C/D, two, what should I call this, folders, I guess. This can represent the root folder to this, or this becomes a subfolder of this folder right here, because this folder right here is the prefix to this folder. So I know that sounds a little confusing. Let's take a look at example 3 so we can really make it make sense even more. So in example 2, we have our input folder equals an array of strings, or representing the folders, we have /A, then we have /A/B/C, then we have /A/B/D. Output is just /A. Explanation says folders /A/B/C and /A/B/D will be removed because they are subfolders of /A. So as you can see, since we have this one /A right here, this is a prefix to this folder and this folder, which means this is the root folder and all of these are subfolders. So we can remove those and we just return this. So you see how this has just one slash and one A, right? It's no other characters in this string. Just going back to example 1, if there was a /C, then that would be the root folder for all 3 of these. But since there is no /C, we're just working with we're gonna go with what we have, right? So we have a /CD and we have a /CF or /C/F. So these are 2 different folders, right? This is a different folder than this folder, but this right here is a subfolder of this folder, which is why we removed this folder. But since this is not a subfolder, or excuse me, this is not a subfolder of this folder, and this is not a subfolder of this folder, then we could return both of them. Now, once again, if we had this /C, then all of these would be subfolders of this /C, but there is no /C in this array, so we have to just keep going and keep pushing through, which means that this is its own root folder and this is its own root folder, since this root folder is not included in the string or in the array. Now let's take a look at example 3, where all 3 folders are their own root folders, right? So in example 3, we have the input folders equals array of strings, which are folders. We have a /A/B/C, then we have /A/B/CA, then we have /A/B/D. Now, as you can see, these none of these are prefixes to any of these, right, of each other, right? This is not a prefix to this, and this is not a prefix to this, and vice versa. Now, once again, say we had /A/B somewhere in this array, then this would be all of these would be subfolders. But since we don't have this, in the array, it's not included in the array, we cannot include it in our output. So we can't include it in our output, we have to return each of these as its own root folder. Boom. So that's why the output is the same as the input, because there are no we have no substrings. They're all their own substring. They're all their own string. They are not, even though they have the same substrings, the substring is not included in the array. So these all have their own folders. Boom. So I hope that made sense to y'all. I know it's a little confusing, but now that we understand the question, let's get into the fun part, the actual solution. The solution is way easier to understand than the question was, so let's get into it. First thing we're going to do is we're going to sort the folders lexicographically so the parent folders come before their subfolders. So for that, we're just going to say let sorted folders equal folder dot sorted and put the parentheses like that. Then we're going to initialize our result array with the first folder. So as you can see, our output, which is going to be our result array, is an array. So we need to initialize that, and we're going to use the first folder as the default value. So we're going to declare a variable. We could call it result, and we could set that equal to an array of sorted folder square bracket 0. and that's going to initialize it with the first folder. Boom. Then we need to iterate through the remaining folders starting from index 1. So we're going to say for I in dot dot less than sorted folders, or excuse me, for I in 1 dot dot less than sorted folders, we're going to open up the brackets. And then we're going to get the last added folder path and add a trailing slash behind it. So we're going to say let last folder equal result dot last exclamation point. Then we're going to say plus, and we're going to open up the quotation marks and put a slash in there. Then we need to check if the current folder starts with the last folder. If it doesn't start with the last folder, then it's not a subfolder. So for that, we could say, come right here and we'll say if exclamation point sorted folder square bracket I dot has prefix open up the parentheses last folder, then we can open up the brackets and we can say result dot append open up the parentheses sorted folder square bracket I. Then all we have to do is come right here and return our result array by saying return result. Just like that, y'all. That should be all she wrote. Let's give it a run before we submit it. Make sure it runs properly. Okay, and we have an error. Cannot find sorted folder, so this should just remove the S. Let's run it again. Let's see. Okay, cannot convert value of type string. Oh, sorry, y'all. This should be sorted folder dot count. Boom. Now let's run it. See what happens. That should do it though. Let's see, and it's accepted. Let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 30 milliseconds beats 75% of users. Not too bad. We could get those numbers up, but we'll worry about that as we continue down our LeetCode journey. I feel like this was a good and simple and easy solution that we can all learn from and understand how it works. So that's why I chose it. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.